whenever you want me to start.
We have the pleasure to have Francesca Loria from the Federal Reserve Board presenting flexible priors and restrictions for structural VARs. So let's say 25 minutes for the presentation and 5 minutes for the general Q&A. I'll give you a wave at the 20 minutes mark. Thank you.
It is my pleasure to be here this morning presenting this joint paper with Cristiane and Junior. Some of the students, can they see the, yeah. Some of the students of the RISE course we taught over the last 3 days are here. You might be able to recognize a lot of the material that we taught to you yesterday afternoon. All right, so this is a paper about structural vector autoregressions. And just to get us all on the same page, I want to clarify what I mean by a structural vector autoregression. I mean a system of simultaneous equations of a set of variables that depend on each other contemporaneously, as captured by this matrix A0, but also they depend on their own legs and legs of other variables. And most importantly, it is a system that features structural shocks, so shocks that are not correlated with each other, unlike what is featured in shocks of reduced form VARs, where you have your set of variables on the left-hand side depending on own past legs and legs of other variables. Okay, it's important to make these distinctions because these are two very different representations of a vector autoregression. Now, why do we care about SVARs? They are a very important tool to understand economic dynamics, to understand the effects of policies, and they're also useful to inform and validate DSG models, among many other features, desirable features. All right. Now, what is, in a sense, our problem statement where we started off this project? Conventional approaches to estimate structural VARs rely on that reduced form representation that I've just shown you on the previous slide. And the idea there is that you first estimate the reduced form VAR, and then you apply some identifying restrictions through which you can recover the structural representation of the VAR, where you can now make causal statements, where you can now make scenario analysis, and the like. The problem with separating these two steps is that it can generate inaccuracies. You can, for instance, think that you're being uniform in the way you pose priors on structural objects, but as it turns out, you're not actually being agnostic on the structural objects. They also rely on algorithms that restrict the flexibility and the scope of the priors and identifying information that you might want to bring to the table. And finally, conditional on an estimated parameter vector, in those reduced form VARs, multiple theories derived from that VAR all share the equal likelihood. So that's not very helpful. What is our solution to this problem? We offer a new framework to apply a broad range of priors and restrictions on structural parameters and functions thereof, drawing on a wealth of economic knowledge. What we do is we leverage directly the structural form representation I had on the first slide. we integrate, we combine the estimation and identification in one single step, and we combine identifying information, eliminating the need for separate algorithms. Specifically, we can accommodate a rich set of priors and restrictions. We can accommodate priors on structural parameters. We can accommodate priors on linear and non-linear functions of structural parameters. Think of these as priors on the sign and the shape of an impulse response, narrative sign priors. The prior, for instance, that monetary policy shocks were the overwhelming contributors to the interest rate in October 1979, as Volcker was trying to fight those high inflation rates that Fabio just showed us. Or priors on relative magnitudes of impulse responses. We can also handle equality and inequality restrictions. Think of those as zero and bound or range restrictions. And any combination of the above. And this is nice because we can use it to identify one, a subset, or all structural shocks of interest. And finally, doing this in structural form allows us to do Bayesian model comparison to evaluate different economic theories informing the structural VAR. All right. More benefits of our approach. We elicit transparent and informative priors on structural parameters. So this avoids the imposition of unintended beliefs on structural objects of interest, which was a problem of reduced form approaches I just mentioned before. We flexibly tailor model dynamics to prior beliefs without, however, rigidly imposing them. When you put, for instance, the prior on a sign of an impulse response, the data can still speak against that sign. When you're dealing with sign restrictions, well, that's a restriction. There's no way that you're going to get anything different than what you requested. And finally, we do not rely on iterative procedures, so our framework is very easily scalable to more complex models, for instance, regime switching parameter models. All right. This is the roadmap. I'll go through the methodology. I'll try to build some intuition using a simple simulation study. And finally, I'll offer as an empirical illustration of our approach, replication and extension of the Bologna and Ireland 2021 JMCB structural VAR. And then I'll conclude. Methodology. We already saw this equation. Here I'm just repeating what I mean by a structural VAR. Okay, the simultaneous equation systems. Our set of variables is related to each other contemporaneously and dynamically. There are going to be the structural shocks that are going to have some standard deviations. You can rewrite this equation in this more compact way, where you would have the coefficients governing the contemporaneous relationships being summed up in this matrix A0, and then in the matrix A+, you have the intercept, well, the constant terms, any exogenous variables, and then all these dynamic coefficients matrices. All right. Now, let's think about a simple example. This is previewing what I will show you in that simple simulation study. You can think of, having an equation in mind that describes aggregate demand in the economy, an equation that describes monetary policy in the economy, and you see here there are some structural aggregate demand and monetary policy shocks. You can rewrite this easily in the form that I've shown you before in equation 1 or in equation 2 by collecting all these relevant structural parameters in the various matrices A0, A1, and sigma. Okay. Now, it is straightforward to write down the likelihood of this model. We have normally distributed shocks, so we know how to write down the likelihood of this model, and it's going to look like that. not particularly exciting. So let me move on to something more interesting, the priors. I mentioned we can accommodate this rich set of priors, and this is how it's gonna be like. We can have priors on the overall dynamic behavior of the VAR, and here, since Sims and Ja already offered us a very convenient prior on the structural parameterization of the model, we are just gonna borrow that. For the structural parameters, we can essentially put any prior of our choice on these structural parameters. Okay, you can put beta priors, gamma priors, I mean, very much like you would do for deep parameters in DSGE models. And this is in the spirit of the work that Christiane did with James Hamilton. And then, this is my favorite, we can have priors on any structural object of interest that can be constructed from the VAR. This is essentially analogous to what people are perhaps familiar with here, which is endogenous priors in DSGE models. And they can be applied to linear and nonlinear functions of the structural parameters, as I mentioned. Any structural object of interest that you care about. This could be IRFs, historical decompositions, forecast error variance decompositions, the shocks themselves, you name it. And then the overall prior density is just gonna be a product of all these priors. So you can use these priors in isolation, or you can combine them. Okay, I'll skip this for the sake of time. We can also accommodate inequality restrictions. Think about these restrictions as being very dogmatic priors. So researchers might have very strong beliefs that structural parameters or combinations thereof lie within a given range or take on a certain value. Well, you can either put priors with a very tight variance, or you can just write down these dogmatic priors as hard restrictions. Our methodology allows us to impose non-linear and linear range and inequality restrictions, where you essentially exclude certain parameter values from the parameter space, and also linear equality restrictions following previous work by Junior with Andrew Binning. All right. Once we have the likelihood of our model and the priors that I just discussed, we know how to write the posterior. And we also know that if we want to find the mode, it is enough, very much as in DSGE models, to maximize the posterior kernel of our model. So this is something nice because practitioners do not have to do posterior sampling right away. They could first find the mode, get a kind of quick smell test, as I like to call it, of where the structural parameters are at the mode, how the IRFs look like at the mode, and then move on to do posterior sampling, starting off from this point of high density. All right. As our students have learned over the last 3 days, well, most notably yesterday afternoon, we have made this methodology available in the RISE toolbox, and we very much hope that more and more people will start using it. All right, so I want to show you a simple simulation study, okay? So we start off from this aggregate demand and monetary policy equations. Think of it as a toy model that I've shown you before. And I'm going to simulate data for output or output growth and the interest rate, okay? I'm going to choose a parameterization that makes economic sense. I'm going to simulate data for 200 periods, and then I'm going to use this data to estimate a suite of vector autoregressions using flat Sims and Ja priors. All right, first off, let's look at the true IRFs. The true IRFs, well, they make sense in the sense that output falls in response to a monetary policy shock, and the interest rate responds positively to a contractionary monetary policy shock, okay? Now, I go to the first experiment. As Junior likes to call it, honoring traditions. So we're gonna use a conventional VAR approach where we estimate the reduced form VAR and then we impose some sign restrictions. Particularly, we are going to impose that output responds negatively on impact to a monetary policy shock and that the interest rate responds positively on impact to a monetary policy shock. And we are going to use the Rubio, Ramirez, Wagoner, and Ja algorithm to impose these sign restrictions. All right. In green, I'm showing you the median and 68 credibility interval of the impulse responses estimated through such a procedure where I impose sign restrictions. And good news, right? The procedure works as intended, output falls on impact, the interest rate increases on impact following a contractionary monetary policy shock. I can now show you the histogram of these impact responses for the two variables. On the left, output. On the right, the interest rate. And there are a few interesting points that we can make here. First off, the true impact IRF of the interest rate gets assigned a high density, but it's different from the median. The true impact IRF of output does not get assigned a high density and is different from the median. Most importantly, and this is something that Christiane and James Hamilton formally showed, but was already present in the 2005 Ulik GME paper, the marginal posterior of these posterior distributions of the impact IRFs are not uniform as intended by the procedure, okay? What I think is actually the most troublesome point, however, is that we do not learn anything about the structural parameters in this model. Why? Because the structural parameters that are associated with these structural models that lie within that credibility interval that I've shown you imply a range for the structural parameters between -infinity and 0 for the coefficient that denotes the sensitivity of aggregate demand to the interest rate, and between 0.01 and about 115 for the way that monetary policy responds or loads on output. Okay, this is problematic. Can we do better? So we innovate on the approach. We now use our methodology that leverages on the structural form representation, and we impose priors on the impact IRFs of output and interest rates. So essentially, this prior is going to say, well, the response of output on impact to a monetary policy shock is going to be somewhere between -0.8 and 0. We expect that most likely it will be somewhere here between -3 and 0. And then for values between -0.2 and 0, I really don't have a prior on which one should be most likely, so it's kind of flat. And then we can have normal distribution looking prior on the impact response of the interest rate, and then in red you will see the true values. All right, so we do a bit better by putting these endogenous sign priors, in the sense that before the impact response was somewhere around -0.7. We nudged it up a little towards the true value, now at around -0.5. Most importantly, we considerably reduced the posterior range of the IRFs. Notice that here I'm keeping the x-axis the same across experiments so that you can appreciate that better visually. The true impact IRF of the interest rate is still assigned a high density, and it is closer to the median. However, the true impact response of output is still in the tail of the posterior distribution. And here is perhaps the biggest contribution of just imposing these endogenous sign priors instead of sign restrictions, which is that we also considerably reduce the posterior range of the structural parameters. And the true values lie within that posterior distribution. All right, what else could we do? I mentioned we can put endogenous priors, but we can also put priors on structural parameters. So I consider two cases. I could have a prior on the sensitivity of aggregate demand to interest rate changes, or I could have a prior on the monetary policy response to output, okay? So either a prior on alpha YR or a prior on alpha RY. Notice that both of these parameters enter the impulse response of output and the interest rate to a monetary policy shock. So there is no reason to believe that the one parameter entering the monetary policy equation should be more important than the other. This is how the priors are going to look like. So we're going to say that alpha YR, since this is the negative, is going to be between 0 and -4, and alpha RY between 0 and 4. And again, we have some flat region for smaller values, as we did before. Now, if you put a prior like that, you can do really well. You can essentially recover the truth, or at least approximate the truth pretty well, at least in terms of IRFs. You also considerably reduce the range of the posterior range of the IRFs, and the true impact response of output is outside of the posterior distribution, but close. Okay. You also considerably reduce the posterior range of the structural parameters. And then the same goes through for that case B when you put that prior on the response of monetary policy to output. Okay, let me skip this for the sake of time. Now you could do something better than that, which is that you could put all prior information on the table. You could put the priors on the structural parameters. You can put endogenous priors on the impact response of output and the interest rate. And here again, you would be able to not only approximate well the truth in terms of the IRFs, but also kind of nail on the head the true impulse responses to which you are now assigning a very high density. And also for the structural parameters, you would have them within the posterior range and assign the high density. All right. Takeaways: sign priors and priors on structural parameters can give very helpful identifying information. Combining prior information can be very helpful and is in fact advisable. And priors on functions of structural parameters are a strict improvement over sign restrictions used in conventional structural VAR approaches. Now, I want to show you an empirical illustration of our methodology in the time that remains. Consider a VAR by the VAR by Bologna in Ireland, which is described by this set of variables: inflation, the output gap, and then a mix of the federal funds rate and the shadow rate. In that paper, they consider the following contemporaneous structural parameters matrix, where they have a 0 in the way that inflation loads on the interest rate contemporaneously, and then where they force in the aggregate demand equation the coefficient on inflation and on the interest rate to be one the negative of the other. We can easily accommodate the 0 restriction in rise. We can also impose this relationship between the two parameters by simply saying that this parameter plus this parameter is going to sum up to 0. And then we are going to impose priors that are very close to the original priors used in the paper, just with a larger variance, so a little less informative, on the other structural parameters of interest. Okay, and what I'm showing you here in the gray shaded area is a credibility interval that comes from the Bologna and Ireland VAR, and the straight black line is the median IRF from the original paper, and then the red straight line and the 68% credibility interval in the dashed lines comes from our methodology as implemented in RISE. And you can see that we can replicate pretty well what has been done in that original paper. All right, let me show you what happens if I decided to now extend this VAR to consider more variables. So here I'm just taking off the shelf, for instance, the commodity price index, total reserves, and non-borrowed reserves from the 2005 ULIC VAR. I slightly changed the sample. It now stops in 2007 Q4, although that is not determinant. And what happens now is that the impulse responses do not quite look like what we had before, right? This might be something that you encountered a lot of times in your applied work. You extend the set of variables, you shorten or lengthen the sample, and things start to collapse. So what comes in handy here is to actually increase the identifying information that you put on the table to try to sharpen identification. And what is problematic here is that, for instance, a demand shock now causes inflation to go down, and a monetary policy shock causes inflation to go up, and the interest rate to barely respond to a monetary policy shock. So what we do is that we bring a wealth of information on the table. For instance, we use ULIC-inspired sign priors. So we want the commodity price index, total reserves, and non-borrowed reserves from 0 to 2 quarters to fall. And we're going to give it this normal distribution. And then we are going to add a bunch of DSG model-inspired shape priors for the responses to a monetary policy shock. For instance, that inflation initially at h=1 and h=3 goes down and eventually reverts back to 0, that the output gap follows a U-shaped pattern in its response. All right, so we are up against a lot of things, but that's not a problem for our procedure. Okay, and this is the last slide I want to leave you with. That is, I'm showing you in blue the new impulse responses that now draw on more information, more priors. And what you can see is that I was able to fix a few things, right? Now in response to demand shock, inflation increases, and monetary policy shocks cause inflation to go down, and the interest rate to respond with a meaningful elasticity. And most notably, notice that other things that I have imposed, like the fact that output should feature a U-shaped pattern in the way it responds, it's not really there. And also, inflation does not revert back to 0 after 4 quarters. This is what I meant by we can impose priors, we can flexibly tailor the model dynamics in one direction, but the data can still speak against it. All right? Summing up, we offer a framework that is flexible enough to accommodate all available sources of information that have been proposed in the literature, with a bunch of other benefits, and all of this will be available in RISE, and we would be most happy if you were to use it. Thank you.
Thank you, Francesca. We have time only for 3 minutes questions, so open to the floor.
Hello, good morning, thank you. And once again, a question from our online audience. Theoretical question, priors for historical decomposition depends on parameters and data. It means double use of data. What is theoretical disadvantage for it? Should I repeat?
Yes, please. I'm not sure I gathered the question.
Okay, a theoretical question, priors for historical decomposition depend on parameters and data. It means the double use of data. What is the theoretical disadvantage for this?
Right, so priors for historical decompositions do not have to depend on data. Even if they depended on data and we were to use data again, it could just be that you either learn something new or you don't learn something new, and that would be reflected by the fact that your priors would have no consequence on the posterior. But typically, priors for historical decompositions come from, I guess, economic theory. For instance, in the paper by Juan Rubio Ramirez and Antolin Diaz, they have this narrative sign restriction where in one specification, for instance, they want monetary policy to be the overwhelming contributor to the interest rate in October of 1979. And so that is not data-driven, that kind of comes from economic knowledge that at that point in time we knew Volcker was trying to fight inflation, and so we would think that monetary policy shock were the overwhelming contributor of that variable at that point in time.
Time for another quick question. Okay, if not, then we can move to the next presentation. We need a little bit more time for switching to the, to the new deck. In the meantime, let's thanks again, Francesca, for the interesting presentation. So let me, in the meantime, introduce the next speaker. Magali